Hi, in this video I'll show you how to work with limiting reactants. So sometimes you're not given a perfect number of moles or grams of an element to work with. Limiting reactants is the reactant that limits the number of products that the equation can produce because there's not enough of it. Now we can tell the limiting reactant in a chemical equation by step 1. Alright, I'll type these out. Step 1, looking at the number of moles or grams of two of the reactants that it gave us. Now it has to give us two reactants in order for us to find the limiting one. Number 2, divide both by the corresponding number of moles in the balanced equation. The smaller number will be your limiting reactant. In this video, I'll do an easy example and I'll do a harder one in another video. So let's start off with a text box. So here's how we find the limiting reactant. How to find limiting reactant. Alright, and here's an example. So when 0.5 mole of aluminum reacts with 0.72 mole of iodine to form aluminum iodide, how many moles of the excess reactant will remain? Now, excess reactant is basically what's not the limiting reactant. So let's say you have 5 moles of hydrogen and 1 mole of oxygen. And when you form them, that's not a very good example, but you get the idea. Since there's only 1 mole of oxygen, you can only use 1 mole of hydrogen. And then you'll have a resulting 4 extra moles of hydrogen that cannot be used in this reaction due to the limiting reactant, and that's the 4 moles of hydrogen will be the excess reactant. Now, remain. How many moles of aluminum iodide will be formed? So first things first, we have to write down the chemical equation. We have aluminum, solid. Metal by itself is always solid except for mercury, plus iodine. Iodine is always I2. That's how gases work. To form aluminum iodide, ALI. ALI 3, because aluminum is 3 plus and I is only 1 minus. So this is not balanced. 2, in order to get to 3, we need to both have them both equal to 6. This way there's 6I over here and 6I over here. Now there's 2 AL over here. That's why there has to be a 2 AL over here. So this is a balanced equation. There. Okay. Now, after everything is balanced, we can write it down. We have 0.5 moles. Actually, I'll write them somewhere else, so because we'll need this space for later. So we have, I'm not sure where to write them. Yeah, I'll just write them over here, it doesn't matter. We have 0.5 moles of Al, but there's 2 moles of Al, so in this balanced reaction, so we have to divide this by 2, and we also have 0.72 moles of iodine, but there's 3 iodine over here. That's when we have to divide this by 3. This equals 0.25, and this 0.72 divided by 3 is 0.24. The smaller number is your limiting reactant, so our limiting reactants will be iodine. Now let's actually do the reaction. Reaction before, change after. So our reaction is 2ALS plus 3I2. A gas by itself is always a gas. yields 2Al(I3). We have not learned how to find the states of matter for Al(I3) yet, so we're going to leave that blank. Now before, it told us we have, again, alright, here's something. After you find these two numbers, you figure out the limiting reactants, you find 0.25, you find the limiting reactant, but you will not use these numbers again to write them in the before place. You'll use what you're given, not these. You will not use these and write them over here, 0.25, 0.24, no. You will not write these. It told us you have 0.5 moles of aluminum, so this has to be 0.5. Over here, when you're writing, always write what the question told you already. Now we also have 0.72 moles of iodine. 0.7 moles here to 0.5. Now I also told you we have 0.72 moles of iodine. Okay, these two has to equal to 0, and this place is also equal to 0. The question asks for how many moles of aluminum iodide will be formed, and what is the excess reactant. So first, 0.5, we will work with the limiting reactant first. Limiting reactant is iodine, so we'll work with iodine first. Minus 3/3. This 3 came from here, this 3 came from here, and in order to make it equal to 1, we have to put a 3 on top, because this has to equal to 0. And you multiply everything by your limiting reactant, which is 0.25 moles as it's given. So here's how I got the 3 on top. You have a 3 on the bottom, multiplied by 0.72. 0.72 minus something divided by 3 times 0.72 has to equal 0. Therefore, this number over here has to equal to 1. 1 times 0.72 is 0.72. When you subtract it, it has to equal to 0. So, because it's the 3 over here, and you get a 3 by using 3 moles over here. So that's why you have 3. Now that's equal to 0. Now let's work with the excess reactant, which is Al, which has a higher number of moles, higher number over here. So change, we're going to use what we have over here, 2, divided by 3, which is what we have over here, times the same number, 0.72. Oh, this is no longer 0, because remember, this is an excess reactant. This is excess. So after this, you'll have some extra left over. 2 divided by 3 times 0.72. All I'm doing right now is putting my calculator 0.5 minus 2/3 times 0.72, and I get 0.02. Now that's how many moles of Al is excess / leftover. This is your excess. Excess reactant. 0.02 moles of excess reactants remain. Now let's work over here. This is plus number over here divided by what we start off with, which is 3. Again, same as here, because both of these have 2 moles. So you'll find your answer will be 0.2. You'll add 0.72 as well from what we have over here. The 0.72 will stay constant through all the changes, because this is the limiting reactant. This number is limiting reactant, and you'll use these throughout. You'll use these for all 3 of. You'll use this number for all 3 of these changes. Now 0.72 times 2/3. 0.72 times 2/3 gives us 0.48 moles. So after this reaction occurred, we'll end up with 0.48 moles of 2Al(I3). Thank you for watching.